Hello dear children, welcome back to foundation course in chemistry. We are learning periodic table and periodicity in properties. Let us begin our session. So today in this session we are going to understand the periodicity in properties in detail. Dear children, we represent the element as ZXA, where X is the symbol of element, Z is the atomic number, or it is in other words number of protons, and A is mass number or atomic mass, or in other words atomic weight. A is the sum of number of protons and number of neutrons present in the nucleus. The number of proton which is equal to number of electron only in neutral elements. In cations, number of protons are more, electrons are less. In anion, number of protons are less and electrons are more. Hence, number of protons becomes equal to number of electrons only in neutral elements. And number of neutrons we can get by subtracting number of protons in atomic mass or mass number. We see the representation of orbital. S subcell which can have maximum 2 electrons and it is the representation of its one orbital. P subcell is having total 6 electrons and there are 3 possible orbitals, px, py and pz. This is the type of representation. One up arrow, 1 electron, another down arrow, another electron. So orbital can have maximum 2 electrons. D subcell is having total number of electrons 10 and there are total 5 orbitals, and F subcell which can accommodate maximum 14 electrons and there are total 7 orbitals. Moving further, we learn to write electronic configuration for element. First thing we are going to do is we need to identify the number of electrons present in neutral, anionic or cationic element which is given to us, and place the appropriate number of electrons in S, P, D and F orbitals in the increasing order of their energies. What is the order of energy? We see now. This is S orbital, 1s, 2s, 3s, 4s, etc. P orbital, 2p, 3p, 4p, etc. D orbital, 3d, 4d, 5d, etc. and this is F orbital. N is number of cell. First we are going to fill the electron in 1s orbital, capacity to accommodate maximum 2 electrons. Next move back to 2s, again 2 electrons we can give. Move back to 2p, give 6 electrons, then come back to 3s. Move back to 3p, give 6 electrons, then come to 4s orbital, and the process continues. 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, etc. We see the order now. 1s orbital to be filled first, then 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, etc. How many electrons to be filled in S, P, D and F orbital? We learned in the previous session and also in the previous slide as S can have maximum 2 electrons, P can have maximum 6 electrons, D 10 and F 14 electrons. Example: carbon 6, carbon 12, number of electrons are 6. So electronic configuration is 1s 2 electrons, 2s 2 electrons, remaining 2 electrons in 2p according to their increasing energy. Next example: oxygen, atomic number is 8, hence electrons also 8, 1s2, 2s2, 2p4. Sodium, total number of electrons are 11, 1s 2 electrons, 2s 2 electrons, 2p 6 electrons and 3s 1 electron. We learn the general electronic configuration for s, p, d and f orbitals. S block elements, first group and second group elements are known as s block elements, and the definition for s block elements is differentiating or the last electron enters into s subcell. The general electronic configuration is ns 1 to 2. Moving further, p block elements, group number 13 to 18 they are known as p block elements. Definition is the differentiating or the last electron enters into p subcell. The general electronic configuration for p block elements is ns 2 np 1 to 6. Moving further, d block elements, from group number 3 to group number 12 they are known as d block elements. The definition for this is the differentiating or the last electron enters into d subcell. The general electronic configuration is n minus 1 d 1 to 10 ns 1 to 2. Next, f block elements. These are also known as inner transition elements as they are taken out from transition elements. The differentiating electron or the last electron enters into f subcell, they are known as f block elements. The general electronic configuration is n minus 2 f 1 to 14 n minus 1 d 0 to 1 ns 2. We learn to write electronic configuration for few elements. Hydrogen, which is having 1 electron, the electronic configuration is 1s1. Helium 1s2. Lithium 3 electrons 1s2 completely filled, remaining 1 electron in the next higher energy level 2s1. Beryllium, atomic number 4 means number of electrons are 4. Electronic configuration is 1s2 2s2. Boron 5 electrons 1s2 2s2 2p1. Similarly, carbon, nitrogen, oxygen, fluorine, neon, which is having total 10 electrons 1s2 2s2 2p6. Sodium, next electron enters into 3s orbital. Magnesium, aluminium, total number of electrons are 13 1s2 2s2 2p6 3s2 3p1. So next electron to be filled in 3p for silicon, so that becomes 3p2. Phosphorus 3p3. Like that you try to write the electronic configuration for remaining elements. Moving further, periodic properties. First one, atomic radius. We know nucleus is present at the center of an atom, around which there is a presence of orbits or cell in which there is a presence of electrons. Atomic radius is the distance between center of nucleus to the valence cell where the electrons are present is known as atomic radius. Atomic radius, along the period it decreases because the electrons are added into same cell, and down the group it increases because electrons are added into new cell. You can see here, first group atomic radius is going to increase down the group, whereas from here atomic radius it is going to decrease because electrons are added in the same cell. So the trend is like this: atomic radius along the period decreases and down the group it increases. Moving to second property, ionization enthalpy. So there is a nucleus at the center of atom, different cells or orbits, and there is a presence of number of electrons. After passing some amount of energy to the valence cell electron, it is removed from that place. The definition is the amount of energy required to remove the valence cell electron from an isolated gaseous neutral atom is known as ionization enthalpy. Factors affecting ionization enthalpy. First one, size of atom. So there is a first atom, second atom, third atom. You can observe there is a presence of different number of cells in 3. So size of atom is going to increase from left to right. So the first one is having smaller size, second increase in size, third even bigger than compared to other two. It means as the distance between nucleus and valence shell electron increases, it becomes easy to remove the valence shell electron because there is a decreased attraction between nucleus and valence shell electron. Therefore, atomic size increases, ionization enthalpy decreases. We require less amount of energy to remove the electron as the size of atom increases. Second factor which is going to affect the ionization enthalpy is nuclear charge, which is similar to the previous one. Nuclear charge or effective nuclear charge means it is a capacity of a nucleus to attract the valence shell electrons. As the distance between nucleus and valence shell electron increases, attraction decreases. Therefore, nuclear charge, if it increases, ionization enthalpy decreases. Moving further, third factor which is going to affect the ionization enthalpy is shielding or screening effect. Due to the presence of inner orbit electrons, the outer orbital electrons experience less attraction by the nucleus. As shielding effect increases, ionization enthalpy decreases. We learn the trend. Ionization enthalpy along the period increases because atomic size decreases, and down the group it decreases because atomic size increases. Moving to third property, electron gain enthalpy. So there is a nucleus, different cells, different number of electrons present in different orbitals. It is the amount of energy released when an electron is added to valence shell of an isolated gaseous neutral atom. It is known as electron gain enthalpy. So the amount of energy released when the electron is added to valence shell. Trend is electron gain enthalpy along the period it increases and down the group it decreases. Smaller the size, addition of electron liberates greater amount of energy. Along the period increases, down the group decreases. Moving to one more property, electronegativity. It is the capacity of an atom to attract shared pair of electron towards itself is electronegativity. As the radius of atom decreases, electrons get closer to the nucleus of an atom, hence electronegativity increases. So atomic size increases, electronegativity decreases. And also nuclear charge, if it increases, electronegativity also increases. So the trend for electronegativity is it increases along the period and decreases down the group. We consolidate these properties. First one, atomic radius, along the period it decreases, down the group it increases. Second one, nuclear charge, along the period increases, down the group decreases. Third one, ionization enthalpy, along the period increases, down the group decreases. Fourth one, electron affinity or electron gain enthalpy, along the period increases, down the group decreases. Moving further, electronegativity, along the period increases, down the group decreases. The last one, shielding effect, along the period it increases and down the group it decreases. Thank you, dear children. Hope you enjoy the session. Thank you very much.